Okay, in this section we're going to take a look at continuing to solve right triangles, but in this particular examples we're going to look at two-sided cases. So this is going to bring up some new of our trig functions, some new trig ratios and functions, and we're going to be dealing with now the arc or inverse trig function. So that's arcsine, arccosine, arctangent, often also just referred to as inverse trig functions. You'll see those on the calculator with the little inverse notation, sine, and up here I have sine to the -1, cosine, and I have cosine to the -1, tangent, and I have tangent to the -1. So that's inverse tangent, inverse cosine, inverse sine, or arcsine, arccosine, arctangent. Those are synonymous, they're interchangeable, so depending upon the text or what you're working on, it may refer to them as either or. So if we look at these cases down below here, these are really just some calculator problems, and what I'm attempting to do is ultimately cancel out or undo, just like if you're solving an algebraic equation, trying to solve for, say, x. In this case, I'm trying to determine what theta is, and so I have to ultimately kind of cancel or undo this sine function, and I do that with the inverse, with the arcsine. So here's what that looks like. So if the sine of theta is 3/5, then I can take the inverse sine of sine theta, and since I'm doing it to this side, I need to do it to the other side, so that would equal the inverse sine of 3/5. And so these would cancel, and I would have theta equals the inverse sine of 3/5, and we just do that in the calculator here. So it's right here, I hit second inverse. And I guess first thing to always check here when we're dealing with trigonometry is to go to mode, and in this case we're wanting degrees, so let's make sure we're in degrees. The default again is always radians. And I'm going to go second sine, takes the inverse sine of 3/5, and I can either put that in here as a fraction, 3 divided by 5, or if I prefer, I can do the same thing with a stacked fraction, alpha y equals, and I'll put 3/5. Either way nets you the same result. They're the same. So that's 36.9 degrees. So in this case, theta equals 36.9 degrees. And that's my solution. Now, a slightly more complex one here with the cosecant of theta equals 1.1. So that's the reciprocal of sine. So what we'll do, clean a little bit of this up, is if the cosecant of theta equals 1.1, then the sine of theta would equal its reciprocal. So this is just written as a fraction, this would be over 1. So the reciprocal then, sine of theta equals 1/1.1. That would be this reciprocal. And now that I've gone ahead and changed this to sine, I can easily take the inverse or the arcsine and undo it. So now I can say that the arcsine or inverse sine of sine theta equals the inverse sine of 1/1.1. And again, in the calculator, I can take this as inverse sine, and I can put this in as a stacked fraction, 1/1.1. And I get 65.4. So in this case, theta equals 65.4 degrees. And the last one here dealing with tangent, so to undo, to cancel, and just get to theta, I'm going to go ahead and take the inverse tangent. So the inverse tangent of tangent theta, with the calculator over here, equals the inverse tangent of 4.8. And we'll do that in the calculator, second tangent, 4.8. I do not have to close the parentheses. You see I did not in these two examples above. It makes no difference because there's no other operation going on in there. And that equals 78.2 degrees. So you really were introduced to these in geometry when you were trying to find the missing angle measure given two sides of a right triangle. So this should be a topic that you're actually fairly familiar with. And we'll look at one of those cases right here. You would have seen this exact same type of problem in geometry. Now I have a right triangle, and instead of what we saw in the prior section where I knew the angle one side and was trying to find the missing side, I know the sides, but I don't know the angle. So in order to find that, we use the same ratios, but we're going to use the inverse trig functions in order to solve for the angle measure for theta. So this is my reference angle, which means with respect to this is the opposite side. This is the adjacent side. This is always the hypotenuse. It's opposite the 90, the right angle. So I have the opposite and adjacent. If I write my little acronym here, so TOA, the opposite and adjacent right here is this tangent. So the tangent of the angle of theta is equal to the opposite side over the adjacent side. So the tangent of this is equal to this ratio. So in order to undo this, to cancel it out, I'm going to go ahead and just take the inverse tangent of tangent theta. So if I do it to this side, it's an equation. I'm going to do it to the right side also. So the inverse tangent of 12 over 5. And we'll pop that up in the calculator here. Inverse tangent, 12 divided by 5. And I get 67.4 degrees. So theta equals 67.4 degrees. Okay, let's take a look at another example. So again, similar setup. I know that B, side B is 90. I know that C is 212. And it wants me to solve the triangle. So I'm going to find all the missing pieces, which is really only two other things. Now, how do we find the missing side or the third side of a right triangle? I'm going to use the Pythagorean Theorem. So I'm going to set this up with 90 squared plus A squared equals C squared, which is 212 squared. Go ahead and crunch these. I don't know what they are off the top of my head. So I have 90 squared, 212 squared, so I have 8100 plus A squared equals 44,944, and we'll go ahead and subtract 8100 from both sides. So I get 36,844, and then we'll square root both sides. And I get approximately 191.9. So there's A. Now if I want to find the missing angles, we're going to go ahead and set up our ratio. Let's find theta. Here's my reference. So with respect to that angle, this is going to be the opposite side. This side's always the hypotenuse, and this is the adjacent. So I'm dealing with, I have all three. I'm going to go ahead and elect to use B and C because these were given values and they're exact. This one I had to round to 0.9, so it is not exact. These ones will give me a better approximation for theta. So I'm going to use the adjacent and the hypotenuse, so my trig ratios. So TOA, adjacent hypotenuse is going to be cosine. So I'm going to go ahead and set that up. So the cosine of theta is equal to the adjacent side over the hypotenuse. So in order to solve, I'm going to go ahead and take the inverse cosine. And I'll do that on my calculator. So I have the inverse cosine of 90 divided by 212. That's approximately 64.9. And we know that this angle then, beta, is going to be the complement. So it's 90 minus 64.9. And we get 25.1. So with that, it only required me really to solve for two things: Pythagorean theorem to find the missing side, my trig ratios to establish the ratio here. We got cosine for the adjacent to the hypotenuse, and then we use the inverse or arc cosine in order to solve for the angle, the complement, and I have every piece of this triangle. So we're going to do a similar setup here, but with new numbers. Let me slide this up just a little bit onto the page. So we'll build this again. So in this case, A is 5.3 and C is 9.8. So we're going to find all the missing information. So again, I'm going to use Pythagorean theorem here. So I'm going to say A squared, so that's 5.3 squared plus B squared equals 9.8 squared. 5.3 squared, 9.8 squared, and then I subtract. So I get 28.09 plus B squared equals 96.04. I subtract, and B squared equals 67.95. I square root. And I get approximately 8.2. So there's my other side. Now I'm going to find the angles. So I'm going to go ahead and call, this time we'll say, actually let's do the other, and then it'll allow us to use a different trig ratio. So again, from here, this reference angle, I have the hypotenuse, I have the adjacent next to, and I have the side opposite across from. So ka, toa. And I'm going to deal with the ones given because they're exact, which was the hypotenuse and the opposite. So that is going to be the sine. So the sine of my angle is equal to the opposite over the adjacent. So to undo this, I take the inverse or arc sine. So I'm going to crunch that in the calculator here. So sorry, that's inverse. Inverse sine. And I get approximately 32.7. And then I find the complement, which is 57.3. So the only thing we've added again in this lesson is the inverse ratios, the arc functions, the inverse functions, arc functions, arc sine, arc cosine, arc tangent, and we're going to use those when we have to undo the sine, cosine, tangent in order to find the angle measure. So it's the two-sided case of a right triangle. We use those inverse functions in order to solve for the angle. Any questions? Bring them with you to class tomorrow, and we'll go ahead and get a little more practice.